hide that. And so we're going to briefly go over the differences between Pythagoras and trigonometry. Okay, so let's first of all look at what Pythagoras is saying. So this value c here, we call this the longest side of our right angle triangle, and it's always opposite the right angle, and we call that the hypotenuse. Okay, so you may have heard of that, hypotenuse. Now the hypotenuse we refer to as c, and the other two angles can just be a and b. We're talking Pythagoras at the moment. And it just so happens that apparently this side, or one of these two sides squared, plus one of the other two sides squared, is equal to the square of the hypotenuse. That's simply what Pythagoras says. Okay, and if we were to experiment with with a couple of by drawing a few triangles, we will see that is in fact the case. One of the most standard examples of this would be, let's say if it was 3 and then 4. So let's say A was 3 and B was 4 centimeters, millimeters, whatever measurements you fancy. Then we're saying that c squared is equal to 3 squared plus 4 squared, which is therefore equal to 9 plus 16, which is 25. So c is the square root of 25, which is 5. So this is a standard 3, 4, 5 triangle, and it's the simplest Pythagoras triangle that demonstrates that has like whole number sides and so on. But Pythagoras, so Pythagoras is used whenever you're not interested in angles at all. So there's nothing to do with angles here, it's only lengths of sides, but it is right angle triangles. Okay, so that's Pythagoras. So only angles. Whereas trigonometry, for a start, we must have an angle if it's trigonometry. Let's use a different color. So we'll use yellow when I'm talking about trigonometry. And we'll make it slightly thicker, I think, as well. And so the angle on a right angle triangle, when we're talking about trigonometry, we label as theta, which is like a little circle, and you go back around through the middle. It's a Greek letter. And the side that is opposite the angle we refer to as O. And then this side that is next to, so O for opposite, okay? Opposite. And then the side that is next to the angle we refer to as A for adjacent, which just simply means next to. And then the side that is a hypotenuse we refer to as H, the hypotenuse. So it causes a little bit of confusion that we have these 3 different letters that change from depending on whether you talk about Pythagoras or trigonometry. But you'd have to blame Pythagoras for that. Pythagoras came along with his rule before trigonometry was discovered, I believe. Anyway, all certainly done separately. So that's the equation for Pythagoras. So what's the equation for trigonometry? Well, there's 3 equations. And what you do is you use your calculator, and you've got these buttons sine, cos, and tan on your calculator. And they essentially, what they do is they convert an angle into a sort of ratio of sides of a triangle, I suppose. So ratio of lengths of sides of a triangle. I'll explain what I mean. So let's say, for example, if we let's move this to the right a moment, and let's say that sine theta. What's sine theta equal to? Let's move this down. Actually, I'll put cos there, and we'll put tan. Whoops, I'll put tan just below. So we're going to look at cos theta, tan theta, and sine theta. What does sine theta equal? Sine of this angle is equal to this opposite, the opposite side, divided by the hypotenuse, that side. And let's Let's move these down again. I'm just going to zoom out also. And then we've got what does cos theta equal? Well, cos theta apparently equals the adjacent side divided by the hypotenuse. And I'm going to keep changing my mind about where I want these things to go. And then we've got tan theta, and tan theta is equal to the opposite over the adjacent. So you can see different trigonomic functions have different are considering different sides of the triangle, but they all have an angle. So once again, Pythagoras you use Pythagoras when you are not interested in any angles and you don't have any angles at all, so you don't need to know them and you don't get given them. Then Pythagoras is the way to go. But if you are given an angle, or maybe you want to find an angle, then you're going to use trigonometry. So, so now you may have heard people saying "so ca toa" before. Whoops, and you might think, well, what's that got to do with trigonometry? Why do people keep saying "so ca toa"? Well, it's because it's to remind you of these three equations. So if we have a look, the first letter of sine theta is S. S-O-H spells so. C-A-H spells ca. And T-O-A spells toa. So, so the way to think about that is that, let's say, so if we do an example question, in fact, let's do one of the example questions on this worksheet here. So we've got this one here. Calculate the angle BAC. Now this is bringing just one other thing into it, and this is this notation of calling angles with three letters. Basically, the angle is going to be at A, and it's going to be between B, A, C. So they mean that angle. You might want to say, why didn't they just call it angle A then? Well, the reason for that is because you could have lots of points and you don't need to necessarily have lines. And if I said, if that was called A, I'm going to just choose a different thickness pen again now. If that was called angle A, if that was called point A, let me just shrink that again, and that was called point B, and that was called point C, I can still say A, B, C, and I would know it would go from there to here to there, and then I'd be that angle. So they want you to get used to this notation, even though it's fairly obvious but invariably it's just going to be the angle at A. Okay, so angle BAC, what is it? Well, that's the theta, that's the angle. The side, this one is opposite the right angle, so that's the hypotenuse. And this is opposite the angle, so that's the opposite. So we look at, what do we have? We've got O and H. Oh, that spells O, so that sounds like so. So I want sine theta. So it's going to be the sine function, sine theta or sine BAC, let's just say sine theta, is equal to opposite over hypotenuse, which is equal to the 12 over 13. And then we put that into our calculator. Now, this is when we get a bit, then we need to bring in one other thing, because what I'm working out there is sine theta, not theta. Okay, so let's just find out what sine theta is. Okay, so sine theta is 0.923. Now that's not what theta is. So how do we get theta? We need to do something. So this is a special function. We need to do the inverse function. We need to sort of like undo the sign in order to get that. And so the way that you do inverse functions, and this comes up in a functions topic as well, we say that theta is equal. So we say therefore theta is equal to sine to the -1. And this does not mean powers. This looks like powers. It's not powers. It means an inverse function. But essentially, you're undoing the sign. So we're going to do the inverse sine of 0.923. So how do I get that on my calculator? Well, next to the sine button, you'll notice, and probably in yellow writing, it says sine to the -1. So to get that function, you press Shift. There's a Shift button on your calculator, and then you click the sign, and then you do 0.923. Okay, so that's going to be 67 degrees to the nearest degree. So that's trigonometry. Now we can, if we wanted to, we might as well, because we want to really see the differences between and similarities between trigonometry and Pythagoras, let's also bring in Pythagoras as well. So what is the length of side AC? Do you want to see if you can work that out? So you got a squared plus b squared equals c squared. So we eventually want to say b equals something. We want to rearrange that. Now so to rearrange any formula at all, any equation, you simply want to do something to the left and then do exactly the same thing to the right. So on the left-hand side, the most sensible thing to do, I think, is to start by removing this a squared. So to do that, I will just take it away. But because I've taken it away from the left, I've got to take it away from the right. So we end up with b squared is equal to c squared minus a squared. Whoops, minus a squared. That's not b though, that's b squared. So what do I do next? I square root b squared, which means I've got to square root the bit on the right. So because I've got a nice funky whiteboard app, I can just delete that squared symbol and then just draw the square root symbol on the right hand side like that. So b is therefore equal to the square root of c squared minus a squared, which would be equal to, in this case, would be equal to the square root of 13 squared, because that's what 8 is, minus 12 squared. And when we tap that into our calculator, let's get rid of this stuff, this doodle now. So when I tap that into my calculator, I get, so that's going to be that, and then that's going to be the square root of 25, which is 5. So b is equal to 5. So that's the difference between Pythagoras and trigonometry. Trigonometry is when you're considering angles of a right angle triangle, and Pythagoras is when you're only considering the 3 different sides of a right angle triangle. Okay.